And we're live. Okay, so welcome everyone. We are excited to be here today. As I mentioned earlier today in our Facebook feed, we are interviewing lots of experts that have everything to do around growing healthy produce, living a healthy, balanced life, and making habits around that. And super excited, Planted Places. We are all about helping health-minded people learn how to grow food so they can live the healthiest life possible. And when we do that, we're really talking about doing it in living soil. And that is why today we're super excited to talk to Dr. Tom Wilson. He's got a PhD in soil and water science. And I'm going to let him talk a little bit about what that means. Probably means a lot about dirt and soil, but it's a great thing and it's super important for us. And I want to just spend just a minute here before we get going to talk a little bit about what we're doing this week. We are introducing a new product into the marketplace called the Planted Box membership. And here's why we're doing it. We've got these great farm walls where people grow organic produce on a wall using living soil. And what we've learned is there's a lot of people out there that want to do this, especially with COVID. They want to understand where their food's coming from and want to learn more about growing food. Tom's going to talk a little bit about that. And what they want to realize though is people think they have a brown thumb, Tom. They get pretty nervous about this. They don't quite know what they do. And I can relate to them because I used to be there. I've gardened all my life. I love being around soil and ornamental flowers and such, but I was always intimidated about growing food. And in fact, I sort of avoided it. I would try basil and that would go bad really fast. And what I learned is it's really a lot about the soil. In fact, it's kind of all about the soil. And so I went to work and pulled that together and we created our systems, and I really want to bring that to people. And the important part of what we're doing this week when we launch our membership is we really want to educate people. And so it starts out first with you, Tom, because the most important thing here, of course, is the soil. We want to talk about that and why that matters and what people need to know. And that's a big part of our membership is training people through that and coaching them. But then midweek, Thursday, we're going to talk with Colleen Heber, and she is actually, she's got she's got a course around stick habits. And basically, it's really about creating habits. There's a lot of good habits in life and a lot of bad habits. And how can you find those good habits? And guess what? Farming and gardening is a habit that you kind of create a ritual out in that garden. So we want to talk about that. And whether it be urban garden or a garden in your backyard. And then, of course, Saturday, we're going to talk about food. And what do you do with all this great food that you're growing? And, food is medicine. And so we want to talk about that too. And that's probably something you know about as well, Tom. But let's no further ado, let's get started with Tom. And I think let's start out and tell us a little bit about your background and kind of, why you got into soil and everything that you do, because you've done a lot of neat things.
Yeah, thanks, Christy, and thanks for allowing me to be here as well. I'm really excited about what you're doing, and of course, talking about soil is something I love to do. As a kid growing up, I grew up on a farm in Virginia where our family spent the summers, and I just remember my grandparents' garden, and you could make a meal out of a single tomato. It tasted so good. And I was so impressed. I'd make tomato sandwiches, or we'd have them in salads and things like that. Corn, I'd help shuck the corn at the end of the summer. It was an entire ritual. It was an entire process, and I just love that. And spending the rest of the year and growing up in Arizona, where I spent the rest of the time, I noticed over the years a trend where tomatoes, for example, really did not taste the same. Mm-hmm. And so when I went to school, I learned that the primary function or purpose or goal for breeding tomatoes out here was for durability. It wasn't for flavor or nutrient content. It was for cosmetics and durability. And it just had virtually no flavor. And that's when I realized that taking responsibility for food is something that's really an important thing to do, because it's what we put into our bodies. And how best to do that? Well, to take good care of yourselves, you have to put good quality food into yourselves. And that comes from soil, because either directly or indirectly, as I mentioned in the preview earlier today, about 99.7% of the food that we eat comes from soil. And that's based on a National Geographic article that came out several years ago, and the cover story was called "What the World Eats," or Where Food Comes From. And so when I went back to grad school to work on my PhD, I just realized how vitally important and underappreciated soils really were. And I decided to focus, even though I've had a lifelong interest in natural history and the environment, I wanted to focus more on soils and get down to the, if you will, the nuts and bolts of it, whether it's for preserving ecosystems or it's for growing sustainable food. And so that's what led me in that direction, Christy.
That's great. I love that. It's so aligned with what we're doing as well. And I think we're going to have you come on another time to talk about kind of the ecosystems and what that's all about, because there's such a bigger story here too, right? But I guess let's start out with just a real basic thing. I use the word living soil a lot. And can you talk a little bit about like what makes a soil living versus not?
Yes.
Yeah.
So, you know, the one thing, there's several different definitions of soil, but the common element among all those different definitions is that it has to have the capacity to support life. And that's why what we've seen on the moon not be classified as soil. And to date, what we've seen on Mars, you bring back these samples, they're still not classified as soil because, at least in the case of Mars, we haven't identified anything that can support life. And that's really what helps make a soil alive, the capacity to support life. And pun intended, digging deeper into that definition of soil, what makes it alive, that's where the microbes come in, the things that we can't even see. And you essentially see a soil as a dynamic, and it really is an ecosystem into and of itself. It's really dynamic when you see, say, manure or compost added to a soil. Well, the plants can't take that up directly. They cannot take up organic material into their roots directly. They need a conversion. And the process to develop and have that conversion is through the microbes. It's called decomposition. And whether it's fungi or bacteria or arthropods like earthworms and things like that in the soil, they're taking the organic material that's added to the soil and they're releasing it as converted into plant nutrients that the roots of the plants can take up. And so it's vital for a soil to actually be alive for plants to be sustained. It can't just be a way to provide, you know, water to the roots or even structural stability for the plants to remain upright. You've really got to have those dynamics, that conversion process that only comes from a living soil.
So Tom, real quick, how do the organic fertilizer, how do those get into the soil in the first place? So, and how are the microbes, how do those get there?
Sure. So when you talk about natural ecosystems, you can be looking at leaf litter. The leaves fall off the tree. That's an organic material that's been added to the soil. And the microbes decompose that leaf litter and release the nutrients that the plants can then take up or take up again in terms of recycling. So otherwise, in terms of organic materials that we can add, you can add compost, for example, that can be readily decomposed. You can add a mulch, and a mulch can be something that helps stabilize the soil to prevent it from disappearing, eroding away, but that can take much longer to decompose.
You want to think about kind of which one decomposes. So that's interesting, because when I think about our soil, you know, we do things like we've got like alfalfa meal in there, and we've got something like biochar in there. And so I know you've mentioned to me before about like alfalfa is good because it's a quick source of organic material. Yeah, which is cool. Let's talk about so let's talk about maybe some myths about soil. Like, you know, you threw out a number, 99.7%, you know, of the soil out there. So what, you know, why is that number so high? And, you know, what are some things about that we need to know, or at least be maybe concerned about or not concerned about?
Sure, and it's not intuitive because 99.7% of the food that we eat is not plants. It could be for some of us, but not necessarily all of us. And so you have to take a next step for people who eat meat, and that is the meat that they eat, the animals that contribute that meat had to eat plants.
Mm-hmm.
For the most
Right.
part. And those plants came from the soil. And so that explains the 99.7%. So in terms of the totality, that's one thing that people don't really get. Another myth is that dirt and soil are the same thing. And to a soil scientist, dirt is a 4-letter word. And yeah, you could say soil is too, but it's the wrong kind of 4-letter word. And the reason that there's a myth about dirt and soil being the same is that, and one of the dangers of conflating two, making or thinking that they're the same thing, is that actually dirt is a negative connotation, right? Your hands get dirty. You track dirt into the house. And the fundamental difference between soil and dirt is that dirt is soil out of place. In other words, it's settling on your rooftop. It is something you're bringing into the house. And dirt, fundamentally speaking, is not alive. It's not capable of supporting plant growth when you're taking it out of what's really the soil. And so that's another myth that a lot of people don't really appreciate.
Yeah, and this is
Yeah, go ahead.
Oh yeah, no, I'm just kind of laughing at myself because I think when I was trying to grow food, I was not very cognizant of the fact that, you know what, you need to have a lot more organic material in there so that those roots and those plants can, the microbes can do their job, right? And I think I don't want to call it dead soil, but I guess it was probably pretty close to dead soil because I was literally like putting a little hole in in the ground and and putting it in there and thinking I was doing the right thing using like potting soil or something, but it obviously was not working for me. Yeah. Yeah. Well, okay. So one thing I want to talk about too is kind of the difference between inorganic and organic fertilizers, and kind of one of the things that that is so important, I think, for us at Planet Places is that we are using soil. And we're not using, there's a lot of, in terms of doing this at home. And the most common thing people think of is hydroponics, and I'll get that question sometimes. So why aren't you just doing hydroponics? And I really like to emphasize, the soil is so important. And there's a lot of, we were talking about the nutrition, but there's also there's just the fundamental, like getting your hands dirty, like getting them in the soil and working the soil, working the earth. I mean, there's those components too. But can you talk a little bit about, what does a hydroponic system do versus growing in actual soil, whether it be raised bed or, or containers like we're doing in the wall?
Sure. So the difference between hydroponics and growing plants in hydroponics and growing plants in a soil is that you've got essentially a sterile environment with hydroponics. And the plants cannot take any kind of organic material in hydroponics. In other words, you cannot add compost to hydroponics because being sterile, there's nothing there. The microbes aren't there to decompose that organic material. So you're limited with inorganic fertilizer. And just to back up, to clarify, what's the difference between organic fertilizer and inorganic fertilizer? So an organic fertilizer, simply put, is the plant nutrients that are derived from an organic source. So the top nutrients that plants need is nitrogen, phosphorus, and potassium. Those are some of what we call the macronutrients, the ones they need in the most quantities. And the number one is nitrogen. And so in inorganic fertilizers, it is not derived from organic material. It's actually commercially produced or mined or extracted from the ground. And I just want to talk to you for a second here about nitrogen, inorganic nitrogen. So here's another myth, or a thing that a lot of people don't appreciate or realize, is that the industrial process for generating nitrogen inorganically is directly connected to fossil fuels. And so you need fossil fuels to be able to take atmospheric nitrogen, the nitrogen in the atmosphere, and convert it to a form that the plants can take up.
Wow.
And so that's something that a lot of people don't make the connection about either, is that you worry about fossil fuel use, people wanting to reduce fossil fuel consumption and this kind of thing. It's all over, all the different applications. It's not just transport. It's also industrial processes like this. And so there's a connection there directly between fossil fuels and hydroponics. And so you have to think about that as well.
Yeah. Yeah. So no, oh, I'm sorry.
Yeah.
Go on. Because I think you're probably going to say what I'm about to ask.
Okay. Yeah. So in terms of a soil based fertilizer you add to the soil, it has to be alive to be able to convert the organic material you add, the fertilizers you're adding, to the plants can take up. But the other thing I want to touch on real quick too, organic material, when you add it to the soil, it's kind of a panacea because it's not just providing nutrients for the plants. It's also promoting some of the physical characteristics of the soil. It makes it more stable. It promotes drainage so that water can pass through the soil. But at the same time as it does that, it also promotes water being retained in the soil, the roots to be able to take up. So it's kind of a win-win situation. When you want to work with soil and plants, you've got to have some kind of organic material added to that. So it's kind of a long-winded response to your question, Chris.
No, I mean, that's great. This is complex stuff, and I'm amazed at how you're able to keep it up, leave it up a level where I can follow you. I mean, it's interesting. You know what? It seems to me like it's extremely efficient system is what it is, kind of what I'm hearing you say in terms of when you're dealing with kind of soil and living soil. There are so many more things going on than the breaking down of the organic fertilizer so the roots can take it up. I mean, it's the, and another thing I wanted to ask, because I get this a lot, is nutrient density in the food that you're growing. So that seems to me, based on what you're saying, is kind of the healthier your soil is, the healthier those plants are going to be. Is that a true statement? I mean, am I thinking about that right?
Yes. No, absolutely, because the plants, they basically have a food value associated with them. And you could have the same species of lettuce, for example, or cultivated variety, if you will, of lettuce or another crop. And you can have them grown, say, through organic versus inorganic fertilizer added, and you'll get a big difference in food value. And the reason for that is that it's the nutrient concentration it's greater and more diverse in the organically grown food than in something that is, for example, inorganically grown. You're getting not just the nutrients, the plants aren't just getting the macronutrients, they're getting some of the micronutrients as well. And when you add all those together, that increases the food value of the plant.
And does that also equate to the taste? Because one thing that is so crazy for me, I mean, this is going back to what you originally said when you first were talking about the tomatoes. But I love to tell this story because I've got my 19-year-old, and he grew up and he did not ever have vegetables like his entire life. It was the bane of my existence. And then I started growing the produce on the wall, and he came, and this last summer he comes over and he's all, "So Mom, what are these leaves?" He calls them leaves, And he's like, "Can I try a leaf?" And I was like, "Okay." I'm like, "Wow, well, okay, fine. You call that, that would be a kale leaf." And he took that, and it was so crazy because he was like, "Oh my God, that's really good." And that was like literally 19 years old. And it kind of changed the way he thought about leafy greens. And it was, there he was every morning going out there. Arugula, same thing. And it was interesting. My other son, who does eat salads, was like, "Mom, I didn't know salads could taste this good," because there's just so much. The food is so rich and vibrant in its taste. And is that also kind of equated to the nutrient value that's there? Is it?
I mean, we talk about the aesthetics of taste, but it's really the chemistry of taste. Our taste buds are interpreting the chemistry of the plant or other food that we consume. And there's a very important reason for that. Our taste buds are what allow us to determine if what we're eating is toxic, for example. Um, and so, you know, the other end of the spectrum, a quality food experience is reflected in its taste. And so associated with that, well, you might say Oreo cookies or something else is high food value because they taste good, right? But in a fundamental sense, when you're talking about lettuce grown organically versus inorganically, the one tastes better. That's directly connected and correlated with the food value and the nutrient content.
Mm-hmm. Yep. And I could see that because, you know, oftentimes you will have a lettuce that truly tastes like water, right? It doesn't.
Yeah.
Yeah. We've all experienced that. So, and it is true. Once you start growing food, your own food organically like this, it's really hard to go back.
Yeah.
You know, it really is. So you kind of want to start growing more. Exactly. So is there anything else in terms of, see, because what's interesting when I think about, okay, so if I'm feeding my food kind of inorganic fertilizers,
Mm-hmm.
and it's not, and the soil is not feeding the roots, if you will, how does that happen? I mean, how does the roots absorb that? They're just absorbing the water that's flowing through it. I mean, how, you know, at the simplest level, how is that working?
Well, in the case of hydroponics, or when you have the equivalent, you have a relatively sterile soil, you're attempting to grow plants, you're adding an inorganic fertilizer, it's what is called root interception. You've got aqueous, a water diluted, dissolved fertilizer that you're adding, and the roots may collect that. But over half of what's added to the soil is not even taken up by the plants. And it can end up in the groundwater, or it could end up being eroded away and end up contaminating freshwater sources or saltwater sources. We've seen this time and again where poor agricultural practices have contaminated lakes and streams. And it's, you know, you have a term called eutrophication, and it's just, it can kill fish and other things. So you can have all kinds of problems with that. The advantage of an organic amendment, though, is it helps stabilize the soil. It helps kind of keep things in place a little bit more. And I also want to touch on the concept of sustainability, because it's a sustainable practice if you're able to grow food where you're composting, for example, so your food waste gets converted right back. You're creating your own little ecosystem in your backyard, or in whatever scale that you have. And in a fundamental sense, that is more sustainable than, say, something that is linked directly to fossil fuel use, where you're having increases rates of soil erosion, soil loss. And I will also, to give some context, around the world today, people have not, in a very broad scale, commercial scale agriculture, they have not identified a way to develop sustainable agriculture. And what that means is this: you cannot farm an area of land year after year indefinitely and get the same quality of harvest. You know, that's why people have to rotate crops, or they have location. And the downside of that is that when you have an area that, say, is laying fallow, it's exposed to erosion and soil loss. And, you know, here's something a lot of people don't realize is that, say, in the breadbasket of the United States, where a lot of our food is grown, to this day, about 5 tons of soil per acre are lost every year from wind and water erosion.
Wow.
That is not a sustainable practice. And so this is where a case where we can, on a very local scale, kind of take responsibility for the food that we eat. Not only are we promoting the food value, promoting our lifestyle, our health, we're actually promoting the health of the soil. You're creating something that's more sustainable, at least on the local level. And so that's why I'm really excited about what you're doing, Christy.
Yeah, it's like you're right. It's kind of like a groundswell. You start educating people and they understand the importance of it. I mean, that's amazing, the stat that you just pulled out there. And it's what can be done to prevent that erosion. You know, I mean, what are some things that we can actually potentially be doing that we're not doing today?
Absolutely. Whether you're a farmer with a large scale agricultural operation, or you've got a garden in your backyard, it means protecting your soil. And there's different ways you can do that. You can put something on top of the soil like a mulch. You can actually, if you're growing crops on a hillside, you do what's called terracing the soil, which means basically creating a stepped side, and that's created more sustainable agriculture for hundreds of years, and people have done that. You can plant windbreaks, so you have barriers of hedges and trees on the edge of your field to prevent the wind from taking it away. And the other thing I'll point out just real quick here, a lot of your viewers probably drink coffee, and coffee is not sustainably grown for the most part. And the reason is this, is that people want to really rush production of the coffee bean. And so through industrial processes that are not sustainable, you can generate a coffee bean from a plant within 3 to 5 years. But the problem is this, you bladed all of the tropical area, all the tropical forest where these plants grow, and you put in these coffee plants, and then after about 8 years to 10 years, your soil has lost all of its nutrients, it erodes away. But there is an alternative called shade-grown coffee, where you actually plant the coffee plants in the midst of the pre-existing tropical forest. And this is an example you can scale down to your backyard, Christy. So the tropical plants actually lose their leaves. They fertilize the soil organically. The soil is stable. And yes, it does take longer to generate a coffee bean. It takes about 8 years versus the 3 years through a commercial process. But the coffee tastes better, and the coffee plant will live over 20 years, generating year after year coffee beans that taste better. And so that's why I always recommend look for shade-grown coffee in your stores.
Yeah, that's great. And that's something, it sounds like that is a new initiative that they are doing now, right? I mean, this is a practice that they're starting to do in some of the tropical. That's wonderful. I love hearing these stories. I mean, it's funny because I thought where you were going to, which is, one of the home remedies that you hear is, if you are drinking your coffee, you take your coffee grinds, and, that is very much like liquid. I feel like that's gold for your compost, and for, when you're composting, that is something, because it's so rich, that I will put back into our composter to get that, my worm bin, I'll add that into that as well to get that, organic material in there, which is a practice. I'm sure you've heard of that as well. But, I will say too, that's one thing in terms of just talking about composting. A lot of our customers will tell us, because, we do have that material called biochar in our soil that we provide for people. Yeah. And it lasts, a long time. And what we do is, and it's got a very high, I mean, you probably could talk about biochar. I think we should have a whole session just on biochar, because it's an important element. Very high surface area. So while we're growing in small pots, it gives it a much larger surface area for the microbial activity. But what we do ask people to do is, after you've been growing and you've been replenishing some seedlings in there for a while, take that out and recharge it in your composter or in your worm bin. Recharge that, and the biochar recharges, which is really nice. So I've got people living, in apartments where they don't have a yard, and they're like, I just started composting because I do not want to lose this soil. And so which is what it's exciting, because we're seeing people at a very kind of urban level to start doing this. Because oftentimes people think, oh, I can't compost. I don't have the space. But it actually is possible to do that even in a small space. So very good. Any last, thoughts you want to leave for us in terms of how to think about soil and when you're growing food? And I mean, there's been a lot of stuff here, and I have a feeling we're going to bring you back.
Okay. Yeah. And I just wanted to touch on something that, in a very simplistic sense, not all organic material that you add to the soil is created equal. Okay. It doesn't always decompose at the same rate. And so for soil scientists use what's essentially a currency of decomposition, and it's the ratio of carbon to nitrogen in your organic material. So for example, alfalfa, the alfalfa plants are nitrogen fixers. So they have a pretty high nitrogen content. And what that means is that they can be decomposed pretty fast. And you can get that decomposed, get it converted to a plant nutrient the nitrogen, ammonium and nitrate, that the plants can take up.
Yeah.
At the other extreme, you might have sawdust. And sawdust has a very high carbon content relative to nitrogen, and it may take years to decompose. So these are some thoughts that you might have in terms of, what are you composting with? Is it something like that can be readily decomposed, relatively high in nitrogen, that you might have, like the soft tissue of plants, or is it something kind of like, bark or the equivalent?
Mm-hmm. Yeah, and that actually, it's interesting because it makes me think with our farm wall customers and with the future planted box members, we provide the soil, and we actually provide the organic fertilizers as well. And one thing that we look at in our mix is, do we have slow release nitrogen and faster release nitrogen? So that so when you go and you transplant that seedling, it can actually start, it's got immediate available nutrients to start bringing, because it can be broken down quickly. And then you've got others, so you've got this lasting fertilizer, which is very great. And it's one reason why you're able to keep growing produce, kind of month after month in these smaller containers. So yeah. Good. Well, very good. Very exciting. And I want to thank you very much for the time today and telling us about soil. Soil can get, and I appreciate you not, like, I'm sure you can go really deep with that. And I think it's great. I think our people out there have some new knowledge about what does it mean, organic fertilizers, inorganic fertilizers. Why are we working with soil? And what is the importance of soil? And so many more elements in terms of having such an efficient system in terms of growing food. And probably most importantly is it really produces good tasting leafy greens, which is, at the end of the day, it's what are we putting in our body that, it could be healthy, but does it taste good?
Right.
Yeah, exactly.
Very
Well,
good.
great. Yeah. Well, good. Well, thank you so much. And thank you, everyone. Again, remember this week we are doing our Planted Box membership. And so we close the cart on Saturday. So go ahead and reach out to us at plantedplaces.com or just send us a message on Facebook or Instagram if any questions. Great. Thank you so much, Tom. Awesome.
Thanks. My pleasure.
All right. Bye-bye. Bye, everyone.
Bye-bye.